Hey everyone, I'm going to start off by reviewing problem 17, and I may go ahead and review problem 18 as well. So this will be the review video for problem 17 and 18. There are 128 pencils to be put into boxes. So we know the total is 128 and we have to put them into boxes. Each box can hold 9 pencils. So 9 in this box, 9 in that box, and so on. So how many boxes can be completely filled? So we're looking for how many full boxes. They're not asking how many leftover pencils or if there's a remainder. We're just focusing on how many completely filled or full boxes. So since we know our total of 128, and we know that we're going to put 9 pencils in each box, we're going to use the equation 128 divided by 9. Okay? So I'm taking that division strategy, and I'm going to get my strategy set up. If I only have 1, it's not enough to make a group of 9. 0 goes there, and I still have that 1 left over. Bring it over to the 2 to make 12. 9 can go into 12 one time. We can make one group of 9, and one group of 9 is exactly 9. So when you subtract 12 minus 9, you have 3 left over. Bring that 3 up to the 8 to make 38. Now thinking of our multiples of 9, 9, 18, 27, 36, and 45 wouldn't be too much. So 38 is not a multiple of 9, but we can get really close with 36 without going over. So 4 groups of 9 equals 36. And when you subtract 38 minus 36, you're going to have a remainder of 2. Okay, so we have an answer of 14 remainder 2. Let's talk about what these numbers mean. So we're putting pencils into boxes and we're trying to fill up as many boxes as possible. So we have 14 filled boxes. So 14 boxes that are completely filled, and then our remainder 2 represents 2 extra pencils. Not 2 extra boxes, but 2 extra pencils, okay? So technically, if we wanted to put all of the pencils in boxes, we'd have to get 1 extra box to put these 2 extra pencils in, but that's not what they're asking us. They just want us to focus on how many boxes are completely filled. And so our answer to number 17 would be 14. 14 boxes can be completely filled. Okay? So we are not using the remainder 2 for that particular type of division question. All right, let's go ahead and hop down to question number 18. Switching over to fractions, which 2 of these squares have the same amount shaded? So when we see same amount, we think about equivalent fractions. Which 2 fractions are equal? And of course we have 4 different pictures. So every time we see a picture or a visual model, we need to take it back to fraction form before we even start to look at our answer choices. So when I look at our first visual model, I see that 2 out of the 4 pieces are shaded. So 2/4 represents our first picture. Our other visual model, I see that 3 out of the 1, 2, 3, 4, 5, 6, 7, 8 are shaded. So 3/8 is a fraction to represent that picture. Go down to visual model R, and 3 out of the 4, or 3/4, are shaded. Go to S, 2, 4, 6 out of the 8 pieces are shaded on S. So that's our first step to attack this problem. Take those pictures back to fraction form. And they want us to figure out which two pictures, which two squares have the same amount, which two are equivalent. So when I look at P and Q for answer choice A, P and Q, we have 2/4 and 3/8. Okay. Is there any way I can take 2 and multiply it times something to get to 3? No, there's no way that I can start out at 2 and multiply it times something to get 3. So they cannot be equal. Another way we can figure that out is that 2/4 is equivalent to 1/2. So P represents 1/2 shaded, but Q is actually less than 1/2. So they cannot be equal. Okay, let's go to B, P and S. So P is equivalent to 1/2, but 6/8, which is S, is actually greater than 1/2. So P cannot be equal to S because P equals 1/2, S is greater than 1/2. So they cannot be equivalent. Let's go ahead and look at Q and R. Q, which is 3/8, is less than 1/2. R is 3/4, which is actually greater than 1/2. So if we have one fraction that's less than 1/2, another fraction that's greater than 1/2, they're not the same amount. They cannot be equivalent. So it looks like our fractions R and S, 3/4 for R and 6/8 for S, are equivalent, and that is correct, and here's why. I can take 4 times 2 to equal 8. And remember, whatever we do to the bottom number, the denominator, we have to do the same exact thing to our top numerator. 3 times 2 equals 6. So because we can multiply both the numerator and denominator times 2, that is proof that they are both equivalent fractions. 3/4 is equivalent to 6/8.